this video, we're talking about multiplying binomials, and what we need to know is that multiplying binomials is really just an extension of the distributive property. So let's review the distributive property for a second. I have this example here, x times the quantity 3 plus b. 3 plus b is a binomial because it has two terms. That's where the bi comes from. Remember, bi means two. So 3 plus b is a binomial term. X is not a binomial, so when we multiply x across the 3 plus b, we're not multiplying two binomials together as we're going to do in these other examples, but we're using the distributive property, which tells us that we have to distribute this x across both terms in the binomial. So if we have something, a variable or a real number, outside of these parentheses that's sitting just outside, it's telling us to multiply this value by every term inside of the parentheses. So when we do that, our result is going to be x times 3, or 3x. We keep the addition sign, so plus x times b, or bx. That's the distributive property, and again, multiplication of binomials is just an extension of the distributive property, because now when we have two binomial terms, one is the quantity a plus b, and one is the quantity c plus d, each of these are binomials, we're just going to multiply each of the terms in the first binomial by each of the terms in the second binomial. Now, you've probably heard of FOIL before, and that just tells us how to multiply these binomials. FOIL stands for first, outer, inner, last. So it tells us to multiply our first terms together. So each of the first terms in the binomials, so a and c are the first terms, we have to multiply those together. Then the outer terms, so that's going to be the ones on the outside, which are a and d, so we have to multiply these two together. Then we have to multiply the inner terms, the ones on the inside of this whole thing, that's going to be b and c. And then the last term, so the last term in each binomial, b and d in this case. So those are going to be the four multiplication steps that we're going to do. So let's look at foiling the multiplication of these two binomials. We're going to start with our first term, so a and c. A times c is ac. Then our outer terms, a positive a times a positive d is a positive a d. Then our inner terms, a positive b times a positive c is a positive bc. And then our last terms, b and d, a positive b and a positive d, plus bd. So that's how we FOIL out two binomials. Let's look at an example with some real numbers and variables here. The steps we're going to follow again, we're going to FOIL the terms, then we're going to collect our like terms together, and then we're going to make sure that the answer we write is written in descending order of exponents. So here, if we look at our first two terms, 4x and 2x, we'll multiply those together and we'll get 8x squared. Then we'll multiply our outer terms, that's going to be a positive 4x times a negative 1. It's going to give us a negative 4x, remember, because those signs are different, so we end up with a negative. Then the inner terms, positive 5 and positive 2x is a positive 10x. And then the last terms, positive 5 and negative 1 gives us a negative 5. So we FOILed. Now we want to collect like terms, and if we see here, we have a negative 4x and a positive 10x. Those are like terms. So adding those together, we're going to get a positive 6x. So then we say 8x squared plus 6x minus 5 is our final answer. The terms are already written in descending order because we start with the largest x squared, then we drop down to x to the first, and then we list the constant. So we're done here and done here. Now let's try our final example. FOILing again, we'll get x times x gives us x squared. X times a negative 4 gives a negative 4x. Positive 3 times a positive x gives us a positive 3x. And a positive 3 times a negative 4 gives us a negative 12. We're going to collect like terms. This negative 4 and the positive 3x is going to give us a negative x. So we're going to have x squared minus x minus 12 as our final answer after we multiply the binomials together.